So now let's talk about the concept of a black body, and this is connected to the things that we've discussed earlier about emissive power and absorptive power. So black body is an object which is able to absorb all the radiations of all wavelengths falling onto it from all angles. So first thing that I want to clarify is that a black body does not have to be black in color. It is that body which absorbs all radiations falling on it. So let's look at the concept of a black body. And what it means is which absorbs whole of the incident radiation falling on it within itself and is able to absorb all wavelengths and all angles of incidence. So first thing is that it is able to absorb the entire all radiation of all wavelengths. Two is the fact that since it's a good radiator, since it's a good absorber rather, it's also a good radiator. So it is able to radiate energy of all possible wavelengths. So it's a good absorber over here, and it's also a good radiator over here. And very shortly in the next video, we will look at Kirchhoff's law, which helps us understand why bodies which are good absorbers also are good radiators. For the time being, we'll discuss the black body. So if we go back to this particular point, it is able to absorb all radiations, and therefore, if we go back to the definition of A and A lambda, it's a ratio of absorbed radiation by incident radiation, and since it is able to absorb all radiations, the value of A will be equal to 1, and value of A lambda will also be equal to 1 for a black body. And for a black body, instead of using lowercase a, we use uppercase a. So we say A equal to 1 and A lambda equal to 1. So this is what a black body is. Now, a perfectly black body is a perfect absorber, as I said, and by Kirchhoff's law, it is also a good radiator. It's able to emit radiation of all possible. But at the same time, let's understand this, that it's a perfect body is not possible. It's a theoretical construct. Yes, there are objects which can approximate a black body. For example, graphite or lampblack. They have absorptivity in the range of 0.95, around that values, and therefore they are good approximation of a black body. For practical purposes, Perry designed a black body for us to understand the concept, and this diagram over here shows the Perry's black body. And what it means over here is that, let's say we have an object which is just one opening over here, and radiations come through this and they get reflected over here, and this radiation in some ways get trapped over here, and only if the radiation is falling perpendicular over here like this, it has a possibility of going back. But if I provide a protrusion like this, then that chance also gets decreased drastically, and only this particular wavelength which falls on the tip of this particular protrusion of the same material, of course, will be able to go back. So what happens is this radiation which is gone inside gets trapped inside, and for all practical purposes, this is a black body. Now, as I said earlier, it is not essential that a perfectly black body should appear black. In fact, a perfectly black body is one which absorbs external incident radiations of all wavelengths and emits radiation of all wavelengths when it is heated to a high temperature. One example is the sun. It gives out radiations of all wavelengths, so it may be called a black body even though it looks white. Similarly, if I have an oven which is thermally insulated from all sides and there is no loss of heat, it can be thought of as a black body, though fire is burning inside it. So these are some of the concepts of black body, and in our coming discussions, we will refer to the black body when we discuss Kirchhoff's law and the Wien's law. Thank you.